All right, hello, algebra students. Here we are again with your second video for your winter break lessons. So this is section B, I believe, of Unit 8, and we aren't going to talk about everything in this section until you guys get back, but we are going to briefly look at histograms. So a histogram looks a lot like a bar graph. The only difference is that it displays a range of values. So I just kind of underlined. You guys can see that any section, any number or data point that goes into this bar that I'm kind of scribbling over, okay, falls in between 50 and 55. So that can include 51, 52. It's not one specific number. It's a range of numbers. Okay, so a histogram is a type of bar graph that displays frequency of data points. The horizontal axis is divided into equal intervals. Okay, that's the range that I was talking about. And the rectangles are side by side. So the following histogram gives the heights of 21 students in a class. Answer each of the questions that follow. I believe the first question you guys see is how many students are taller than 70 inches. So when we look at this, we have to count from 70 on. Okay, so that includes this bar, and this bar. So we want to just trace over and see how many students that is. I think that looks like this is going to be 3, and down here is just 1. So that's going to be 3 plus 1, a total of 4 students that are taller than 70 inches. So this is really just reading the bar graph. How many students are shorter than 65 inches in the class? Shorter than 65. So shorter than 65 starts at 65 and is lower. So we're going to include this bar graph, this bar, and this bar. Okay? All right. So let's see. The first one has 4, the second one has 6, and the last one has 5. So we are going to add together 4 plus 6 plus 5, which gives me 15 students that are less than 65 inches. So that's just how we read a histogram, and that's how we actually might evaluate or interpret the results of a histogram. All right, let's go on. The next thing we want to talk about in this unit is how the data is distributed. So when we have data, we like to look at the trends. We like to see how is the data distributed. Is it all even? Is it symmetric? Or is it something that we call right skewed or left skewed? So let's take a look. There's 3 definitions up here, and the first one I want to take a look at is right skewed, which is in the middle here. Right skewed is when I have a bunch of data, or I'm looking at a histogram, okay, and the data has a longer tail to the right. Okay, this just means that the mean is going to be greater than the median. Now, what do I mean tail? Take a look at this shape. If I follow the shape of the distribution of this graph, or the shape of all the data, when I put them all next to each other, you can see that as I move to the right, there is a tail. This means that it's right skewed. So if it says estimate the mean, you're not going to get an exact number because each of these bars in the histogram are a range of numbers. But what we know for sure is that the mean is going to be greater than the median. The median is going to happen somewhere probably in like the 40 to 50 range because that's the actual middle number of all the data, whereas the mean is actually going to happen somewhere kind of on the other end of the spectrum. So at the end of the day, what you need to know is that the mean is greater than the median when the data is skewed to the right. Let's go on. So we just looked at right skewed. Let's go ahead and take a look at left skewed. So left skewed is just the opposite, you guys. It's when there's a tail to the left. As you guys can see, okay, we're actually, if we go down to the left, we have a tail to the left in this case. So this is what we call left skewed. Now in this case, it's a little bit different. The median is going to be greater than the mean. And this is just because it's the opposite. There's more numbers kind of over here, so the median is actually going to happen somewhere in here, whereas the mean might happen more to the left, which is a smaller number. So if it asks you to estimate, just know that what you need to remember is that the median is going to be greater than the mean when we have a graph that is skewed to the left or left skewed. We're going to quickly talk about symmetric next. Last thing that you guys need to know is when the data is distributed in a symmetric fashion. So this is just when it's well balanced on either side of a single peak, okay? So we like it when our data looks like this. It's a nice symmetric distribution. So in this case, guys, the median and the mean should be closer together. They should be just about the same. And that's because it's the median and the mean will happen somewhere right in the middle. So again, we got symmetric where it's distributed more evenly with a single peak being in the middle. We have data that could be right skewed when I have a tail to the right. We have data that's left skewed, which is when I have a tail to the left. And that's about it, guys, from this section. You need to know how to read a histogram. You need to be able to answer questions regarding the histogram. And then you need to be able to tell me the types of trends you guys see when you look at a graph, such as symmetric, right skewed, and left skewed. That's all we got for this section. When we get back, we're going to start with a recap of what you guys looked at over winter break. We're going to go a little bit deeper with sections A and B, and then we're going to move on to scatter plots and lines of best fit. And we'll be done with this unit, and we'll be talking about finals. Hope you guys all have a very happy holiday, a wonderful couple weeks off, and some relaxing, and then, make sure you guys do a little bit of math for us. That'd be great. We'll see you guys in a couple weeks.